Yo, yo, y'all, throw up your foes for NFL for life, nerd for life. All right, here we go. So we're continuing on with our test corrections, and now we're on problem number 4. And so we're given in this a geometric sequence, 3, 6, 12, K, and so forth. Right? This thing's going to keep on going here. And so what we want to do here is first find the first 5 terms. Okay? And one of the important things to note about a geometric sequence is that they have a common ratio, right? So say if we were going to find our ratio, okay, so that means we have to take any pair, whether it be like 3, 6, 6, 12, or 12K, but like I guess we probably wouldn't use the K one because we don't know what that one is yet. But say if we take 3, 6, we can find what that common ratio is, right? So we take our second term 6, and then we divide it by our first term 3, and that's going to give us 2. And again, we would get the exact same answer if I chose this pair. Okay, and that equals 12 over 6, which is 2. So this is how we know that this is a geometric sequence, because it has a common ratio of r. Now, what is so super rad about the r is this is our generator for our next term, meaning I use this as a multiplier. If I multiply 2 times 3, I get 6. 2 times 6, I get 12. 2 times 12, and then I'm going to give my next one. So let's go ahead and find the next 5 terms, because that's what we need to do here. So maybe I'll do it. This is A1, A2, A3. So this is going to be, let's go ahead and find A4, A5, A sub 6, A sub 7, and then A sub 8. All right? So if you want to find our next term, I'm going to multiply my previous term by my r. So I'm going to multiply 2 times 12 then. And hopefully I have no computations errors this time, because the last one messed up big time, man. All right, here we go. So we're going to get 24 right there. So that will be my next term. So now I take 24, and then I multiply that then by 2. All right, let's go here. So we're going to get 48 right there. And then, let's see, we're going to go ahead and then multiply that right there. 48, so we're going to get 96 right there. And then we're going to multiply 48. We're going to multiply, I'm sorry, 96. 96 right there. Good, and we'll multiply it there. So we'll get 192. And then we'll multiply this guy, 192, by 2 there, 90, 50, over there, 92, 384. Okay, 384. And so this is what the power of the r is. It generates our next terms. All right, so coming over here now to our next guy, we want to represent our geometric sequence now as a sum of the first 10 terms using summation notation. And Mr. Nzunza already talked about what summation notation was, which is a fancy way of using our Greek letter sum, sigma, right? So we're going to use the sum, okay, that's what we use our Greek letter S right here, the sum of the first 10 terms. So we want to go from the first term all the way up to 10. So we start at 1, plug in 1, plug in 2, plug in 3, and keep going, and we're going to stop at 10 here. Now, what needs to go right here is the generator, or also known as the nth term. What is the nth term of this geometric sequence? And so our formula that we want to use here is u sub n equals u sub 1 times r to the n minus 1. And this is very simple because we already know these things. Our first term is 3, and our r is 2. Plug those guys in, and we have the representation of the first 10 terms. So our first term, again, is 3 times our r of 2 to the n minus 1. So this represents the sum of the first from 1 to 10 terms. You plug in 1, plug in 2, plug in 3, and you stop at 10, and you take that whole sum. So that's what this represents. And then lastly, part 3 now is do this. What is the sum of the first 10 terms? Okay, and you could do it by hand, which is really long and tedious, and we don't want to do that. Let's go and use our sum formula. Okay, so we want to take the sum of the first 10 terms. Well, let's just first write down our n formula here. So we have s sub n, and we have our first term times 1 minus r to the n, all over 1 minus r. Okay, so let's just plug in our numbers, and then we'll use our calculator to generate our answer. First term, simple, right? Sum of the first 10 terms is our 3 times 1 minus r, which we already know is 2 to the 10, all over 1 minus 2. All right? I most definitely won't do that by hand there, but if we calculate this, let's see, 3 times 1 minus 2 to the power of 10. Get that guy right there, which is a negative 3069, but then we divide by a negative 1. So it's positive 3069. And that would represent the sum of the first term, second term, third term, stopping at 3069.